Good morning. This is Mr. Domingo. It is about 11 o'clock at night. I'm here in Boston. Again, I wish I was with y'all, teaching y'all. Today I had class from 9 in the morning and I got out at 8 o'clock at night, so I've been pretty busy, but I'm still going to teach y'all. First of all, I got some of your assignments from yesterday. I know juniors, you're gone on your field trip, but from the seniors, just want to clarify some things about the project. First of all, if I could switch over to Schoology. I see I have Absidy's, Matt's, Nico's, Tara's, Brittany's, and Justine's. Emily emailed me hers, but there's still a lot of seniors that I'm missing. Um, Unless there's some sort of reason, maybe you need to email me or something, but I'm assuming that if you didn't turn anything, that it'll be a 0. So please submit something or let me know what happened. Secondly, remember the project's due on Monday. I know you don't have school for a 3-day weekend. So I'm sort of expecting a lot. I'm expecting a full effort. Remember, for all my projects, if you do the bare minimum, it's a B minus. I want to be sort of impressed. I want to see a lot of the research that you did. Again, ideally for this project, I'm trying to find, trying to get you guys to find, you all to find, a credit card and savings account that you legitimately will open up. If you don't want to open one up, or if you can't find one, I mean, this whole assignment's made for you. So please, please put in the full effort, or that's how the grading procedures are going to be. So hopefully you guys have taken out your notes for today. It's section 3.1. I handed it out to you a while back. It's actually part review, looking at the definition of exponential function. An exponential function, if you give me a second, an exponential function, there you go. An exponential function is one where it has the format a to the x, okay? So like 2 to the x power, or 10 to the x. Anything that has the variable in the exponent spot is called an exponential function. It always looks like this, so we've done this before. So it has a reference point at 0, 1, and it has an asymptote here at 0, and then it exponentially increases. So domains negative infinity to infinity. I'm allowed to put any numbers from negative infinity all the way to positive infinity, and the range is 0 to infinity because my y values is no bigger than, there's no lower than 0, and it goes all the way to infinity. My horizontal asymptote is y equals 0. Remember, it's a line, and the definition of an asymptote is a line that I'll get very, very, very close to and never touch. So you see this line gets very, very close to 0 and never touches it. It's continuous. That means there's no gaps, there's no holes. It increases, has a positive slope, so you guys see that it's a positive slope. And my y-intercept is also my point of reference, is 0, 1. So always, there's a few things I want you guys to know. You need to always tell me where the point of reference is. I need to know where the new asymptote is going to be. And I also need to know domain and range. So these 4 I expect for all your exponential functions. So let's look at some of the examples as I scroll down to the next ones. So here's some examples. Remember doing translations and reflections. So in this example, do you see I have a +1 here? Since this +1 is with the x, that means I'm going to go to the left 1. So see how my reference point was at 0, 1 before? Now it's moved over to -1, 1, because this little translation means move to the left 1. If this -3, like see how this +1 is included with the x, but this one's not included with the x, that tells me, I don't know why this doesn't want to highlight, this tells me I'm going to translate up and down. So this -3 means go down 3. Here, let me draw it. This -3, right? A little bit different than this +1 right here. So this +1 over here means left 1. But this -3 means down 3. So why does it say 0, -2? Well, remember my reference point is supposed to be 0, 1. So if I move down 3 instead of 0, 1, this will now be 0, -2. The thing that most of you are confused about is the reflections. If I have the minus sign out in front, that means I flipped over the x-axis. So what was once 0, 1 is now 0, -1. And if the negative is with the x, that means I flip it over the y-axis. So what was once, the asymptote is still y equals 0, but instead of going up this way, it's now going to be flip over the y-axis and go down this way. So let's see, based on these examples, again, this is review, can you graph out the following? All right, 3x minus 2, 3 to the x minus 2. First of all, some of you are wondering, what does this 3 mean? What does this 2 mean? For all intents and purposes, remember it makes it skinnier, but we're not going to worry about that for now. Remember, if this number is really big, like this is 100, it gets this graph gets skinnier quickly. It's like sort of compressed. But we're not going to worry about that. Right, so this -2 is with the x, so what does that mean? Yeah, we're going to move it to the right 2. So my reference point was 0, comma 1. So I'll move it over 2 spots to the right. So instead of 0, comma 1, it's now going to be 2, comma 1. My asymptote's still going to be the same, and my graph still looks exactly the same. So remember, if I scroll up real quick, there's a few points that you always need to consider. Always show point of reference, asymptote, domain, and range. Well, my point of reference, remember I moved it. So this is now 2, comma 1. Oops, 2, comma 1. My asymptote is still y equals 0 because it didn't move up and down. And my domain is still negative infinity to infinity. I don't have an infinity sign, so I can just put 2 zeros. Negative infinity to infinity. And then my range, same thing, it didn't move up and down, so my range is still going to be from 0 to infinity. Right, new question. This one says 2 to the x minus 1 plus 3. Well, this minus 1 means the right one. So instead of 0, comma 1, it's going to move 1 to the right. Now it also means up 3. So instead of saying 0, comma 1, let me write this out. My point of reference is always 0, comma 1, but here I'll call this old and new. But since this is included with it, or sorry, since it says to move to the right 1 and up 3, that means I'm going to go 1, comma 4, because that means I moved to the right 1 and up 3. So let me draw that. 1, 2, 3, 4. So here's my new reference point. Remember, and it's hard to understand, but you see when my reference point, if I scroll up, when my reference point is at 1, it got closer and closer to the 0. When my reference point was at 1, my horizontal asymptote was 1 below. It was 0. But for this one, or like here's another example. Here, my reference point was at 1, and then as I moved down, asymptote was 0. So instead of going, or here's my point right here, I'm going to move down 1. So my new horizontal asymptote instead of 0, oops, is actually going to move, my horizontal asymptote also moves up 3. So my new graph looks like so. Probably cleaner and nicer. Right, next ones. I got 3x minus 2. This is simple. It looks like the last one, but instead I got this minus sign out here. Yeah? So this is what I'm going to do. If I look back up, this minus sign on the front means I reflect over the x-axis. So since this looks exactly the same, well, my reference point is supposed to be at 0, 1, but instead I'm moving it to the right 2. So just like the other one, it's going to be 2, comma 1. But then how about this? I'll draw the original problem. Right? But there's this minus sign in front. That means reflect over the x-axis. So I'm going to take the same problem, and here's how the real answer is. I'm just going to flip it over the x-axis. And I forgot to write this out for the other one, but this new one, my new asymptote is y equals 3. My domain is still negative infinity to infinity, right? That part hasn't changed. And then my range, it's not going to be from 3 anymore because I moved it up. It's actually going to be from 3 to infinity. All right, with this one, I moved it down over here, so a lot of things are going to change. My asymptote is still y equals 0, right? My red line is still getting closer and closer to 0. My domain, still the same. I'm going all the way from negative infinity to infinity. I'm allowed to put any x value into this problem, where every x value has a value. But in terms of range, in the past, it used to be like always going up. With my red line, it never goes higher than 0, and it goes all the way to negative infinity. So my new range is going to be negative infinity to 0. Let me just move this. All right, last one. I got, oh man, how am I running out of time already? All right, I got a negative x and a negative 2, and I have this plus 1. Well, first, I'm going to draw the basic, which was my reference point at 0, comma 1, and I need to move it up 1. So do you see how my new reference point will be at 0, comma 2? Oh, still in red, but that's okay. And my normal graph would look like, since I moved it up 1, my asymptote moves 1. So it should look like that. But now I'm flipping twice. I got to flip over the x and y axis. So if you could follow me, I'm going to try to use my camera, but this line is going to flip over once. I'll use a different color. It's going to flip over once this way, right? And it's going to flip over once over the x-axis. So it's also going to look like so I have to move this asymptote here and flipped over. It looks like ta-da. So in my blue line, or my red line, it used to be moved up 1, it should be 0, 2, but since it's down here, this will be at, my new reference point will be at 0, -2. My domain, same thing, I'm still allowed to put any number in, so it's still going to be -infinity to infinity. And then my range, a little bit different. I go no higher than -1, and then go all the way down to -infinity. So I'll write that. Okay. We only have 4 minutes left. I want to talk about this new topic. I think we might have some time later to help explain some of your homework over the weekend. But I'll save that for. I'll post that video tomorrow night. First of all, you need to know this new value called E. You may have heard of it, or you should have heard of it, especially since you're in honors pre-con now. E is the value 2.71828. It's an irrational number like pi. This number keeps on going with no real pattern. And we use it for population growth and then continuous compound problems. So there's a couple of, we'll just focus on 2 formulas you need to know. One is this one, where essentially, if you tell me a certain number of pieces of information, I can tell you how much money you're going to make. So if you tell me P, the principal, like how much do you invest, R, what's the rate, what's the interest rate, and like how many times you compound. Some of you may have heard this term compounds, but when do I pay out interest? Do I pay out interest every day, every 4 months, every month? That's what I mean by compound. If I have N again, and then if I have T, like for how long, I could tell you how much money you're going to make. This one's compounding continuously, so it's pretty much like every day or every second you generate interest all the time. So if you tell me the principal, how much money you put in, E, which is an actual value, right? It's an actual number. And then RT, where R is the rate, like interest. Oops. And T is the time for how long are you going to keep this in your interest or in your savings account. I could tell you how much money you're going to make. All right? So let's start off with an example, and I think we'll only have time to do one example. So let me put the compound interest still on the screen. All right, here we go. So I got a P of $2,500, which tells me that I'm investing, or I'm putting $2,500 in my savings account. My interest is 12%, which is really good. If you're doing your project, your interest should be close to like what percent? Yeah, 1. Your bank will compound it 4 times a year, and you want to see after 20 years how much money does your $2,500 investment make. All right, so first I'll plug it into the formula, which is going to be P, right? P is 2,500, parentheses 1 plus R. R is 12%, so in numbers that's 0.12. It says over N. They told me N is 4 times per year, so I'm just going to compound 4 times a year. And then to the NT, where N we said was 4 already, and time is 20. Now, for this class, you should have a calculator. I'm not looking for a precise definition. You should be able to put this in calculator and get a number. Because I'm doing this over the internet, we're just going to have to stop there. And for compounding continuously, almost the same thing, but except for I remember it by PERT. Sounds like the shampoo. So it's 2,500. Oops. Let's pretend that's 2,500. E to the R is 12%, so it's 0.12. And then time, which is 20. And you can put this in the calculator. You can tell me which one of these makes more money. Is it compounded interest or compounded interest only 4 times a year? So thanks for listening to my lecture. I want you to finish the worksheets. I gave you a packet. It's all about graphing exponential functions. And it'll be due at the end of class. Maybe you can just rip the paper off and then turn it into Ms. Robinson. So take care. See y'all on Monday. Get your projects in on Schoology. No excuses. Put in all your work. And miss y'all. See y'all on Monday.